Okay, starting out today with the conjugate root theorem. It says, guess what, that? You're not near C. If p of x is a polynomial with rational coefficients, okay, with rational coefficients, first of all, rational numbers are numbers that can be written as fractions, okay, and those fractions cannot have a denominator with 0, okay? Okay. If p of x is a polynomial with rational coefficients, then the irrational roots of p of x equals 0 occur in conjugate pairs. All right, just like I have imaginary pairs, I also have rational or radical pairs as well. So if a plus the square root of b is a root, then I will say a minus the square root of b is also a root. Okay, and we talked about this one yesterday. If a plus bi is a 0 of the function, then a minus bi is a 0. Okay? Now, a corollary, or something that follows from what we have just said, okay, is that a polynomial function of odd degree with real coefficients has at least one real 0. So if I have an odd power, that graph has to hit the x-axis at least one time, okay? Now right here it says a polynomial function of f, or a polynomial function f of degree 5 whose coefficients are real numbers and has the zeros of 2, 3i, and 1 plus I, find the remaining zeros of the function. All right, now I know that I have a degree of 5, so that means I should have 5 roots total. Well, I have 2 so far, or 3 so far. I have x equals 2, I have x equals 3i, and I have x equals 1 plus I. Okay? There are 2 roots that are missing. 1, 2, 3, 4, 5. Now remember that I should have conjugate pairs to my imaginaries. Okay? If I have positive 3i as a root, I should also have negative 3i. And if I have 1 plus I, then I should have 1 minus I. These are my remaining 2 roots that I was trying to find to answer that question. Okay? That's it. All right, now it says, find a polynomial of degree 4 whose coefficients are real numbers and have the zeros 2, 2, and negative 3 plus I. Assume that a equals 1 for your leading coefficient. Graph the function to verify your result. Analyze the characteristics of the function, okay? What does this mean? First of all, I have x equals 2 times. I also have x equals negative 3 plus I. So what should that automatically tell me is my remaining root? Not 3 minus I, but negative 3 minus I. The only thing you change is the sign that is in front of the imaginary number, okay? Now, this helps me determine my factors. These are my roots, okay, or the zeros. So now I want to create their factors. So all I do is I start taking these and I start moving those numbers over with the x. Okay, I've got two of those, right? How do I get rid of a negative 3? You add 3, and then right here I would subtract I. And then my last one over here, once again, I would add 3, but this time I will add I. Now, these 4 factors I can take and I can multiply together. Now, I'm going to say negative 2 or x minus 2 squared. And then I have x plus 3 minus I times x plus 3 plus I. I want to build a function. Yes. Okay. So y'all always remember I'm posting my videos, okay? All right, here we go. I want to multiply these together. So I'm going to start right here. I'm going to multiply that together. And then I'm going to multiply these together. All right. This one, I know that it's this x minus 2 times x minus 2. If I do the distributive property, that's going to give me x squared minus 4x plus 4. Now with this one, if you want to, okay, we can do a 3 by 3 box. Just showing you another way to set this up, okay? And I can take each polynomial and I can write those factors on each side of the box. Do y'all remember in biology how you had Punnett squares? Okay, so this is kind of like a Punnett square. I'm going to multiply these together. So x times x is x squared. X times 3 is 3x. And x times negative I, I'm going to say negative xi. Now typically I would put those in alphabetical order, but because my i's I always put in the back, that's why I'm writing it like that. Okay. Now I'm going to go down this column. Right here, I have positive 3x. I have positive 9. And here I have negative 3i. Then I have positive xi, positive 3i. Huh? Nope, these don't cancel because remember, well, hold on. I'm not there yet. Okay, right here, I've got negative I times positive I. This is like negative 1 times positive 1. So that's a negative 1. And then I have I squared.
Do we have to put that one up front?
I would for now. Just because when I have negative 1 I squared, does anybody happen to remember what I squared equals? Negative 1. Okay? If I is equal to the square root of negative 1, if I then go in and I square both sides, the radical cancels out. Okay? Now, so if I squared equals negative 1, that's going to be negative 1 times negative 1. So what's inside here ends up turning into a plus 1. So I'm going to kind of cross that out, and I'm going to put a plus 1 out in the back. Now, right here, I'm trying to combine like terms in this box. The x squared doesn't have anything that I can put with it. Okay? Then I've got 3x and 3x together. That gives me 6x. Then I've got these xi's. One is positive, one is negative. So what happens there? Those cancel out. So to answer your question, yes. Okay. Then I've got this negative 3i and positive 3i. That cancels out. But then I have this 9 and this positive 1. So that gives me a positive 10. Now, doesn't that trinomial look a lot better than all that ugly stuff? Okay. Now, it takes a minute to get there. Okay. But we want to try and work our way through that so that we get rid of the ugly eyes. Notice my imaginary stuff is gone. All right. Now I want to multiply these two together because I want to create one polynomial. Okay. Now, how many of you like this box, or how many of you would rather me just distribute? Okay. I'll do it both ways because I got people shaking their heads at me. Okay. All right. I'm going to distribute first. All right. If I distribute, I have to multiply the x squared times all three of those terms. Okay? That gives me x to the fourth power plus 6x cubed plus 10x squared. Then I need to multiply this negative 4x by everything. What is negative 4x times x squared? Negative 4x to the third. So I'm going to line it up underneath the x cubed. What is x times x squared?
You said 8 times x squared. I thought you said 6x. My bad.
Not yet. What is negative 4x times 6x? What kind of 24? Y'all got to get the signs, okay? Negative 24x squared. And then what is negative 4x times positive 10? Negative 40x. Don't leave off those x's. Okay? And then the last thing that I'm going to do, okay, I'm going to distribute this 4. What is 4 times x squared? 4x squared. What is 4 times 6x? Positive 24x. And what is 4 times 10? 40. Okay? So right here, I'm combining like terms. I have x to the fourth power plus 2x cubed. All right, very quickly. What is 10 take away 24? Negative 14. And what is negative 14 plus 4? Negative 10. So negative 10x squared. What is negative 40 plus 24? Negative 16x. And then plus 40. So this right here, I am calling this function f of x, and this is my big polynomial, okay? I built my polynomial by taking all of those factors and multiplying them out, okay? Now, for those who want the box, okay, I'm going to show you the box right here. Once again, I have another 3 by 3 box. And I am putting x squared minus 4x plus 4 on one side. Then I have x squared plus 6x plus 10 on the other side. Okay? Now, just like a Punnett square. Now, if I'm doing this for you, you better be paying attention. I've got x to the fourth, 6x cubed, 10x squared, negative 4x cubed, negative 24x squared, and then negative 40x. positive 4x squared, positive 24x, and positive 40. What I need you guys to see is that I have like terms on diagonals. So you can combine your like terms right there, and that is your first and last term. Either way, it's still going to go the same way. Okay? And I feel like I just royally wasted my time because you're not even looking up here, but whatever. Okay. I am going to now pull up Desmos. Okay? I'm going to pull up Desmos. Okay, I want to take this function that I just created, okay, and I am asked to graph it to verify my result. Now I'm typing this in. I have x to the 4th power plus 2x cubed minus 10x squared minus 16x plus 40. Okay, now this right here all right, so I can kind of use this as some guidelines. Okay, this graph is hitting the x-axis at 2. Do you notice it is bouncing off the x-axis at 2? Why would it do that? The multiplicity of 2, right? Okay, so I want to come up here now, and I'm just trying to get some reference points. I want to see where this graph hits the y-axis. It hits at 40. So I'm plotting a point right there. I'm going to come up to this maximum, and I know that it's not going to be perfect, y'all. It is a sketch, but this happens at almost -1, almost 46. So I'm going to just estimate where this goes. I'm going to estimate this ordered pair also on my graph. Let's see, almost -3, almost 24. That's going to be somewhere a little bit less than halfway right there. Okay, all I did was put some points on there that's going to help me sketch this out. Now, my power was even, right? So, and my leading coefficient was positive. So I'm just using those points to help me sketch that function. Okay, now it's not going to be perfect, and that's fine. That's why it's called a sketch. Okay, so all I did was use Desmos here to help me just kind of sketch some things. All right, now part C asked me, all right, this was part A. I built my function right here. This was part A. Part B was to sketch my graph. And part C asked me to analyze the characteristics of my function, okay? I want to identify the domain, the range, the extrema, and my end behavior here. Okay? Is there any break in my graph from left to right? No. So my domain goes from -infinity to +infinity. Are my y values covered all over the axis or no, right? Because my tails are both going the same way. What is my lowest y value? 0. So I'm going to say that 0 is included and it goes up to positive infinity. Okay, I feel like I have enough of my graph, so I'm going to pull this back over so I see more. Okay, now for my extrema, okay, we have absolutes and we have relatives. Okay? Now, what can we automatically count out and why? An absolute max, because those tails are pointed up, therefore there will never be a highest point overall. Okay? Now, I do have an absolute minimum of 0. Okay, I am going to pull my graph back up just so I can write down my ordered pairs for the relative max and min. All right, here is a relative min. I have a relative min at 23.954. But where else did I have a relative min? 0. And then the only other thing to write right here is my relative maximum, which is 45.858. Okay? Now, for my end behavior, I am going to use my limit notation, okay? The limit as my x values approach negative infinity, and the limit as my x values approach positive infinity. Where are my y values approaching on both the left and the right? Positive infinity, because they're both pointed up. Now, there are, of course, other characteristics that we could find, like intervals of increase, intervals of decrease, points of concavity, intervals of concavity, did I say points of concavity? I meant points of inflection. I'm sorry. Okay? There are certainly things that I could do there, but I'm not. Okay? All right. Do me a favor, please. Okay. I would like for you to look at this page with me. Okay. Right here, I am given a quintic polynomial. That's an x to the 5th power function. So the first thing I'm going to do is I'm going to say n equals 5. So that tells me that I should have 5 roots and factors. Okay? Now, I am asked to find all the zeros, which are my roots. I am asked to also factor it, okay, over the set of complex numbers. So, I am going to go to Desmos, and I'm going to type in my function real quick. Let's see. All right, y'all call that out to me so I don't have to keep looking up. X to the 5th. Thank you. Okay, perfect. All right, very quickly. Okay, what I want to do is I want to look at this graph. Okay, I'm going to make sure I see my origin, and then I'm going to zoom in for a moment. Okay, do you guys see that this graph, okay, crosses over my x-axis 3 times? Yes? Okay. So I'm going to write those solutions down real quick, okay? Do me a favor, you write that down, and then I'll write it down by what you tell me. Okay, just write x equals -2, 1, and 4. All right, -2, 1, and 4. All right, so these are my real zeros. Okay, these are my real zeros. So that means that the remaining ones, because I did not see it hit the x-axis, that means that these two are imaginary. Well, I got to find those. Okay, so here is what I am going to do. Okay, do you remember synthetic division? Sure. Here we go. I'm going to draw my upside down division bar. Okay? Now, my powers decrease from left to right. All right? So I'm going to take the coefficients. Now, the coefficients here are 1, -3, -5, +5, -6, and 8. I'm going to write those down inside my synthetic division setup. These are the coefficients for my original quintic polynomial. Now I know 3 of the zeros, okay? Now if I divide out 3 of my x's, if I divide out x to the 3rd from an x to the 5th, what am I going to end up with? X to the 2nd power, right? Don't we know if I can get something down to a quadratic function, then I can use quadratic formula like I did yesterday to factor out my remaining 2 zeros. Okay? So here is my process. I'm going to start right here with this -2. This -2 is the first root that I am going to remove. We always drop down my leading coefficient. On the outside, we multiply. So -2 times 1 is -2. And then we add those together. That gives me -5. Then -2 times -5 is +10. -5 plus 10 is +5. Do y'all not remember synthetic division?
The little 7?
Oh, we did that.
I taught college algebra this the other day. Okay. Take out a clean sheet of notebook paper. Huh? Not at the moment. Okay. They should have. Okay, guys, let me teach you this very quickly, okay? All right. Yes. All right, real quick. Synthetic division versus long division. All right? The first thing that I'm going to do, okay, I am going to do a very quick review with you. review, I can't talk. I want us to divide the number 1,234 by the number 5. Okay, let's go back to elementary school for a minute. Because this process right here, okay, I want to show you how this is going to help us. Okay. Very quickly. Does 5 go into 1? No. So I keep going, right? Does 5 go into 12? Yes. How many times does it go into 12? 2 times. All right. Now, what do I do next? 5 times 2. What is 5 times 2? 10. Okay. What do I do with that 10? You subtract it. All right, so this was a positive 10, right? I'm coming through and I'm subtracting it so it changes my sign. So when I subtract, I am left with 2. And then I'm going to bring down the next number, which is 3. Now, I want to know now, how many times does 5 go into 23? 4 times. Okay, so I'm going to put a 4 up here. Should have made that red, I'm sorry. Okay, what is the next step? Okay, but how did I get the 20? 5 times 4. Okay, so I put the 20 there, and then what do? You come through and subtract it. It was a positive 20, now it's a negative 20. Well, 23 minus 20 is 3, and I'm going to bring down the 4. And now I want to know, how many times does 5 go into 34? 6 times. What do I do now? 5 times 6 is 30. What do I do now? Subtract 30, okay? Okay, I get the number 4. All right, now I'm going to stop you right there. In elementary school, middle school, whatever, we would typically put a decimal there, put a 0, pull the 0 down, right? You would have a decimal here, and we would finish that out by putting a 0.5. Yes? Okay. With long division and with synthetic division, I am going to keep my remainder, okay? And I'm going to do something different with it. Whatever my remainder is, okay? All right, I want to show you long division first because I need for you, we will do long division, okay? We will do long division and it serves a purpose in pre-calculus, all right? But synthetic division, fake division is much quicker and easier for us to be able to test polynomial roots, okay? All right, so I want to take the polynomial x squared plus 5x plus 1, and I want to divide it by the polynomial x plus 3. All right. Now, this is what I call my dividend, and this is my divisor. Okay? My dividend goes on the inside, and my divisor goes on the outside. Now, with long division, okay, with long division, I need to pay special attention to this x that's sitting out front, okay? Now, it's almost like I'm asking, what do I need, or how many times will x go into x squared? Or, what would I multiply by x to give me x squared exactly? An x, okay? Now, do you remember how I took that 2 and I multiplied it by the 5? Right here, because I have an x and a 3, it's almost like I have to do the distributive property. You're going to do x times x, which is x squared, You also have to then do x times 3. So that gives me a positive 3x. Okay? Now, what did I do? When I did the 5 times 2 and I got 10, what did I come through and do with that 10? You subtracted it, okay? So right here, what I want you to think of as if you are subtracting this entire polynomial. What that does, if I distribute this negative, that's going to change my signs, okay? So this becomes negative x squared, and this becomes negative 3x. All right, what happens to my x squareds right here? What's x squared minus x squared? 0. They cancel out. That's what I want to happen, okay? And then right here, what is 5x minus 3x? 2x. Perfect. I'm going to bring down the plus 1. I no longer care anything about my original dividend. Okay, I care about this 2x plus 1 now. And I'm looking and I'm comparing what would I multiply by x to give me exactly 2x? A 2. Okay, so I'm going to put a positive 2 up here. And then I'll distribute that. That's 2 times x and 2 times 3. So that's going to be 2x plus 6. Okay? Now I come through and subtract. So that's going to change all of my signs just on that bottom polynomial. Okay? My 2x's cancel. And what do I have? I have negative 5. This right here, because I cannot multiply anything by x to give me exactly 5, that's pretty. This right here is my remainder. Okay? Now with polynomial division, we are going to use our remainder and we are going to put it up here behind my quotient. My remainder was negative 5, so I have a minus 5. But I'm going to create a fraction with it because aren't I still technically dividing this negative 5 by the x plus 3? So I'm going to put the divisor as the denominator of that fraction. And this is my quotient. Okay? All right, I want to do another one with you. Okay? I want to do several because I want you to feel comfortable with our process. Okay? So the next one, I want us to do 2x to the third minus 11x squared plus 9x minus 20. And I want to divide that by x minus 5. Okay, so I'm going to get this set up. I've got the x minus 5 on the outside. And I want you to see I am checking to make sure my powers are in order and that I have something in every position. Okay? Hayden, you okay, hon? Okay, you're just holding your head. I'm just making sure your head's not hurting you. All right, here we go. I've got 2x to the third minus 11x squared plus 9x and then minus 20. I am not missing any of my exponents, okay? Not missing any terms. So I'm good. I am focusing my attention on this x that is sitting out front. Okay? What would I multiply by x to give me exactly 2x to the third? 2x squared, okay? 2x to the second power. So we distribute this. 2x squared times x is 2x to the third And 2x squared minus 5 is negative 10x squared.
I love my phone, but I swear I wasn't on.
I didn't say anything. That was that guilty conscience over
No,
there.
you looked at me and I was scared.
I just heard the noise.
Sorry.
You're okay. Okay, here we go. My next process is to come through and subtract everything. So that's going to change this to a negative 2x cubed. But if I subtract a negative, what happens? It changes to a positive. Okay? So the 2x cubes cancel. Then I've got negative 11x squared plus 10x squared. So that becomes a negative 1x squared. Do you agree that negative 11 plus 10 is negative 1?
Yep.
All right, and then I have to bring the entire polynomial down. You no longer care about your original dividend, okay? My question is, what do I multiply by x to give me negative x squared? Negative x. Negative x times positive x is negative x squared. And negative x times negative 5 is positive 5x. That's right. So when you come through and subtract, it changes your signs. So your x squareds cancel. I now have 9x minus 5x, which is 4x. And then I'm going to bring down that 20, the negative 20. All right. What do I multiply by x to give me exactly 4x? Positive 4. This is 4 times x and 4 times negative 5. So I have 4x minus 20. Okay? Now, come through and subtract. What happens to both of those, y'all? They both cancel out. So I have a 0 remainder. And I'm going to put a little heart right here because I love when I get 0 remainders. That makes my job so much easier. What all does this tell me? Well, first of all, it tells me that x minus 5 times the quotient I just got, if I multiply those together, it will give me my original quotient. It divides evenly, okay? So that means x minus 5 is a factor, okay, of that polynomial. All right? Now, all right, I want to do this one, okay? I want to do x to the 4th plus 5x cubed minus 6x plus 3, and I want to divide that by x plus 3. Yep, sorry about that. Huh? I know. That was intentional. Okay? So you just pointed out to me like I did it on purpose, or like I didn't do it on purpose. I actually did. Okay? I am missing an x squared term. Okay? But when I do my polynomial division, friends, you have to have something there as a placeholder. So I'm going to have x to the 4th plus 5x cubed plus 0x squared minus 6x plus 3. Okay? And I am looking at this x. What time do we get out of here today?
45.
Okay, so I'm going to do this. You have homework. You have one problem for homework. Do it before you go home today. Okay? Hey, thank you for letting me know that y'all had not done that. Okay? I'm glad that I was able to back up and punt.